Hello and welcome to 5 Minutes About Pulsar. My name is Rodrigo Geve. I'm on the streaming team at DataStax. Today I'm going to be showing you functions and the Kubernetes runtime. If you want to follow along and you don't already have a deployment of Pulsar, visit astra.datastax.com, register streaming, and get a free Pulsar instance up and running in under a minute. This tutorial discusses using the Kubernetes runtime model for Pulsar functions. One of the key advantages of using the Kubernetes runtime is separation of concerns between the function worker and the functions themselves. In order of least resiliency is the thread runtime model. With the thread runtime, functions are spawned as threads of the function worker process. Using this model, you run the risk of bringing down the function worker process itself if there are bugs in your function implementation. Next is the process runtime model, where functions are spawned as new processes on the function worker host. With the process model, you run the risk of having functions exhaust resources on the function worker host, which affect all other functions running on that host. Finally, using the Kubernetes model allows for the greatest separation of concern with functions deployed in their own Kubernetes pods. With the Kubernetes runtime, individual functions can be assigned dedicated resources. The Kubernetes control plane is then responsible for the lifecycle of the function pod, offering the greatest isolation of system resources. When Pulsar is deployed in a Kubernetes environment, the function worker is deployed using a stateful set. The stateful set specifies one or more replicas for the function worker, and the function worker YAML configuration file is mounted onto the function worker pods using a config map. In order for the function worker pods to be able to generate and deploy new resources into the cluster, the function worker pods run using a special service account identity, which is then bound to a set of permissions via RBAC. A cluster role and cluster role binding define the set of permissions required by the function worker pods to generate and deploy new Kubernetes resources into the cluster. The function worker deploys functions by dynamically generating Kubernetes manifests and applying those within the cluster. All of the options for configuring the Kubernetes runtime are specified in the function worker YAML configuration file, whose contents are defined in the config map. Some of the options include details for spawning new functions in the cluster like memory and CPU requests, the target namespace into which the function resources will be deployed, the destination Pulsar URL, authentication details for functions to connect to Pulsar, and any Kubernetes labels and or taints required to deploy functions to select nodes within the cluster. Next, we are going to look at how to configure the Pulsar function runtime to use Kubernetes mode. In this example, I am going to use DataStax's Pulsar Helm chart as a guide. Let's explore the essential resources that are deployed by the Helm chart for the function worker. Open up the Pulsar Helm chart in your favorite editor and browse to the templates folder. Under the function folder, you will find the config map template that defines the contents of the Pulsar worker configuration file. This file gets mounted onto the function worker pods. This template includes the logic required to configure Kubernetes deployment mode for functions. In your Helm values file, setting the function.runtime to Kubernetes will include details for the Kubernetes container factory section. This configuration provides the Kubernetes mode function spawner with the necessary details to generate Kubernetes manifests to deploy new functions in their own pods. If Pulsar token-based authentication is to be used, then the Helm chart includes an extra config map which provides the Pulsar token-based authentication details, as can be seen here. There are many configuration options. Let's take a look at a sample Helm values specification and review. In this example, we specify the function worker Kubernetes resource requests and limits. In addition, we specify the corresponding min and max JVM memory settings. The K8s min resources specification is for memory and CPU of deployed functions themselves. Those values are referenced in the function config map template. To customize things further, in Kubernetes mode, the Pulsar function spawner can use a custom class when generating Kubernetes manifests. Let's switch temporarily to the extra Helm template code required to configure a customizer. The template code here should be added to the function worker config map. The code specifies both the function runtime customizer class and the customizer configuration properties. Switching back to the Helm values configuration, in the customized runtime configuration section, you can modify things like where you would like to deploy your function pods. In this example, using the node selector labels and the toleration section, we can specify to deploy function pods in their own node pool. I hope you have enjoyed this quick overview of deploying functions using the Kubernetes Runtime model. If you have any questions or feedback, you can leave a comment below or email us at pulsarquestions@datastax.com. That will go to the Pulsar team here at DataStax. We have lots of Pulsar experts that would be happy to help answer any questions you may have or help with any Pulsar-related problems you may be experiencing. We hope to hear from you. Thanks again for watching this video and have a great day.